answers to 1.5 structure questions. The first one, the melting point of the elements going across the periodic table from sodium to argon increases steadily, decreases steadily, or increases to silicon and then decreases, decreases to silicon and then increases. So if you remember the graph, it goes a bit like this, the metals up to aluminium, then silicon, and then it kind of goes down like that. So it's C, increases to silicon and then decreases. Next question, explain what's meant by the term covalent. There's quite a bit to fit in here, so you have to bear with me. What we're looking for is the electrostatic attraction between a shared pair of electrons and the nuclei of bonded atoms. So, and that's a lot for 1 mark, but you need to know also it's the electrostatic attraction between a shared pair of electrons and the nuclei of bonded atoms. So then the next part of the question asks you to describe the structures of diamond and graphite. So for diamond, each carbon is bonded to 4 other carbons. And the other thing you need to say, because this is worth 2 marks, that's your first mark. The second mark is that you have a tetrahedral arrangement. So you could mention that the bond angle there is 109.5 instead of saying tetrahedral, but either is fine. So then the structure of graphite, you're going to say each carbon is bonded to 3 other carbon atoms. And that's your first mark. And your second mark then is for saying that they are in hexagonal layers. And that there are delocalized electrons between the layers. That's your second mark there. Now, explain why graphite conducts electricity. Again, 2 marks for this. First mark is just simply for saying delocalized electrons. And then the second mark is for saying that they can move and carry charge. And finally, in this part of the question, explain why diamond is exceptionally hard. So you need to say in here that it has a rigid 3D structure with many strong covalent bonds. And of course, if you mention ionic bonds in there, you're shooting yourself in the foot because you're going to lose your marks. Okay, next question is about sodium and chlorine. It says sodium is a reactive soft silvery metal. Chlorine is a poisonous gas. The two react together to form sodium chloride that's essential to our diet. Using a labeled diagram, explain the bonding in sodium metal. So I'm going to start just with a little key. I'm going to put a plus here in a circle, and that's going to be my sodium ion. And I'm going to use a different colour. I'm going to do this little blob of green, and that's going to be an electron. And I'm going to do my best here to draw a regular arrangement here of the ions And of course you can do this more neatly because you're not drawing with your finger on the screen of an iPad. Just putting my plus signs in here to show that those are the ions. And it wouldn't matter what metal I asked you to do. I mean, I've seen questions for gold, for aluminium, for all sorts. And then I'm just putting in my electrons here, just randomly in between. Okay, and then it says, using the label diagram, explain. So the diagram isn't enough, so you need to explain what's going on as well. So I'm going to say three things. We have the regular arrangement of positive ions. And that's going to get me 1 mark. We have random delocalized electrons. That's going to get me a mark as well. And finally, that there are electrostatic forces which hold them together, and that's going to give me my 3rd mark. So that's the diagram and the explanation. Okay, next one. Metals are good conductors of electricity. Explain why the electrical conductivity of aluminium is greater than that of sodium. Well, we know that aluminium has more delocalized electrons than sodium. So that's your first mark, and of course those delocalized electrons are the bits that move and carry the charge. So another mark for that. And of course aluminium's group 3, so it's Al3 plus, sodium's just group 1, Na plus. Aluminium loses 3 electrons for sodium's 1. And what type of structure is present in the element chlorine? So you want to say either that it's molecular or simple covalent. Like I said, molecular covalent or simple covalent, either will get you the marks. So now we have a dot and cross diagram to show how sodium bonds with chlorine gas. Only outer shell electrons should be shown. So we're going to start off with chlorine gas because that's what it's asking for. So here we go, Cl and Cl. So each chlorine has 7 electrons. There we go. And that's going to give us, then we have these 2. I'm just doing them with dots here. That's our 2 chlorines. So then sodium, that's just 1 electron that's outer shell. And I'm going to put my chlorine here. Oops. It's dots. So 1, 2, 3, 4, 5, 6, 7. And that's going to give me then Na plus. And my chlorine with a dot and a cross there. And a minus. So I mean, you can draw them as Na plus and then the chlorine with the negative charge outside, if you like. But because they're only asking for outer shell electrons, the way I drew it the first time is absolutely fine. Name the type of bonding then in sodium chloride. Very simple, 1 word, ionic. And it says the structure of sodium chloride is described as a lattice. Explain what's meant by the term lattice. 2 marks for this. So the first mark is for saying that it's regular or repeated. And the second mark is for saying that it's a structure of ions or particles. Okay, Then, apart from its appearance, give 3 physical properties of sodium chloride. First one, it's soluble in water. Or you could say soluble in polar solvents if you wanted. Next one, high melting and boiling point. Now the reason I've written them together is if you said for one high melting point and for the second one high boiling point, you would only get 1 mark. They kind of go hand in hand. And the third one is that it conducts electricity. Now, remember, it's only when it's molten or aqueous. So that's your third mark for that one. Alright, number 4. A crystalline solid melts sharply at 95 degrees. It doesn't conduct electricity in the solid and liquid states. It dissolves in hexane. What type of structure does the solid have? Well, it doesn't conduct electricity, therefore it cannot be metallic. It doesn't conduct electricity when it's liquid either, it can't be ionic. It melts sharply at 95, so it must be molecular covalent. And finally, which one of the following solids consists of molecular covalent crystals? So you're looking for something which is a small molecule. Diamond is giant, graphite is giant, quartz is giant. So ice, of course, is made up of water, which is a simple covalent molecule. So it has to be C, ice.